So hi guys, another video. This is going to be problems 3 and 4 from the Chapter 35 study guide. This should be another pretty quick one. Um, Frankly, why am I even doing these easy problems? I'm trying out new things with the Chromebook, trying to see how well this works. So I want to make short videos. So here we go. Plus, it's important to remember how to do these problems. These two in particular, very easy to make a simple mistake that you don't want to make. So let's get started. So when we're looking at this, I've got two different circuits with capacitors in them. And in both cases, what are we trying to figure out? We're trying to figure out the equivalent capacitance seen by the battery. So CEQ equals question mark. And what is the unit of capacitance? Think about it. It is the farad. It's an F. So let's do the first one. Problem 1. Yep. So what are we looking at here? I've got three different capacitors. They're all in series. So how do capacitors in series add? Remember, there's a trick to this. Capacitors in series actually add inversely. So capacitors in series add like resistors in parallel, which means the formula we're going to use is going to be CEQ is equal to not just C1 plus C2 plus C3. It's going to be 1 over C1 plus 1 over C2 plus 1 over C3, and we need the inverse of this quantity. So let's go ahead and put in the numbers. So what's this going to give us? 1 over 10 farads plus 1 over 20 farads plus 1 over 30 farads to the minus 1. So for this one, you probably are going to need your calculator to do this. So make sure you get the order of operations right. And there's no great trick to this, really. You're all in physics too. You know how to use a calculator by now. As long as you remember to take the inverse of your answer at the end, you should be in good shape. And if you do that, you're going to end up with the equivalent capacitance of 5.45 farads. Put a box around it. Yeah, we solved for the right thing. We gave it the right units. Does this answer make sense? Again, this is like adding capacitors in series is like adding resistors in parallel. It may seem odd that we keep adding more and more capacitors, and yet the equivalent capacitance is less than that of our smallest capacitor, but that's how it is. So this makes sense. Give it a check. On to problem 2. Not problem 2, problem 4. Why did I call that problem 1? That's really problem 3. There, it's a 3. On to problem 4. This time we have 3 capacitors in parallel. So what's the rule for adding capacitors in parallel? These guys actually add normally, which means our equivalent capacitance is just going to be C1 plus C2 plus C3, which is going to be 10 farads plus 20 farads plus 30 farads. And go ahead, reach for the calculator if you need to. You're going to get an answer of 60 farads. Put a box around it. Quick step, did we solve for the right thing? Did we give it the right units? Yes, we did. So this one gets a check. So hopefully you guys can keep straight the different rules for adding capacitors in series and parallel, and how they compare to the rules for adding resistors in series and parallel. If you remember what the rules are, very, very easy. So hopefully this helps.